Right, let's talk about real numbers and what they are. Well, they're numbers that we can write on a number line. They can be placed or positioned on a number line, but we can split them into two separate types. We've got in our set of real numbers, we've got things that are rational numbers and we've got things that are irrational numbers. So let's talk a little bit about what they are and what the difference is between the two. All the integers, so an integer is just a whole number, like 6 or -6, whatever, they are rational numbers. And I can locate that on a number line. Here's -6 located on my number line. Other things that are rational numbers are any fractions that have whole numbers on the top and bottom. So that's pretty much all the fractions, like 3/7 or 3/7 has an integer on the top and has an integer on the bottom. So any fraction with an integer on the top and the bottom is also a rational number. And just like previously, I can map 3/7 onto my number line. It sits here. It's more than 0, but it's less than 1. It sits about here. What else are rational numbers? Any decimals that are either terminating or recurring. Now, a terminating decimal stops after 1, 2, 3, or a certain number of digits. So for example, 23/8, if I did that in my calculator as 23 divided by 8, I'd get this decimal. And it just shows 2.875, then it stops. It's a terminating decimal. And I can map that onto my number line. Here's 2.875. Recurring decimals have a pattern of numbers that repeat in the decimal. So in your calculator, if you try -9 divided by 11, you'll get -0.818181818181, and that goes on forever. So the 81 is recurring, and we mark that with this little bar over the top of the numbers that are repeating. So if a decimal terminates, or if it's recurring, then it's a rational number, and I can map that onto my number line as well. So what makes an irrational number? What's the difference? Well, you cannot write an irrational number as a fraction, because if I could write it as a fraction, I'd have an integer on the top and bottom, which would make it rational. So you can't write irrationals as a fraction. The decimals are infinite and non-recurring. So the decimal places go on forever, and there's no pattern, there's no recurring or repeating pattern in the decimals. So here's an example. If you do square root of 2 into your calculator, you'll get this decimal. It'll stop only because your calculator runs out of screen, but in reality it keeps going on and on and on. I can see there's no repeating pattern in there, so this is an irrational number. I can still map it onto the number line because it is part of my set of real numbers. So irrational numbers are still real numbers. I can put them on the number line, and I know that 1.414 sits somewhere in here, so square root of 2 sits in here. But it's an irrational number because I can't write it as a fraction, and the decimal is infinite and non-recurring. We write them in a square root form. Most of the time we call them surds. So if you've got an irrational number in its square root form, we call it a surd. There are some other numbers that are irrational, things like pi, for example. If you put that in your calculator, 3.14 blah 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 blah, its decimal is infinite and non-recurring. So it's also an irrational number, but it can be located on my number line. So there you go, you've got real numbers which are split into rational and irrational numbers.